I'd like to turn it over to Mr. Dan Miller, who's going to present for us today. Thank you for joining us, and we'll move it soon.
Well, good day, everyone. I hope you can hear me just fine. Coming to you from the U.S. here. I sure welcome you from around the world if you're joining us. And thank you for taking time out of your day, evening, and some of you the middle of the night for joining us for this webinar on electric vehicle firefighting tactics for first responders. As Heather said, my name is Dan Miller. I'm the Chief of Training here at Hazard Control Technologies. We are the maker of F500 encapsulator agent. I've got around a little over 40 years in the fire service, including 20 years with the Omaha, Nebraska Fire Department, where I was a battalion chief of training and special operations, charge of the training division there. Worked a lot in hazardous materials, weapons of mass destruction. Also responded to thousands of fires, carrying a thermal imaging camera, handling the most challenging fires that came our way as a city. Worked for a lot of smaller rural communities, suburban communities as well, including as fire chief in Columbus, Nebraska for 4 years. Served on as a volunteer in a small rural community for 38 years, where I grew up outside of Omaha, and was a part-time instructor with the Nebraska State Fire Marshal Training Division for 19 years. So as we all like to say, we think we've seen it all until the next call, and then we're like, wow, now I've seen it all. But so today we're going to talk a lot about vehicle fire tactics and Hazard Control Technology is the manufacturer of F500 encapsulator agent and several other solutions for industrial hazards, as well as proportioning solutions. We've been in the business of manufacturing our encapsulator technology for 29 years as of this year. We protect over 6 continents, and we've done lithium-ion battery fire testing since 2008. Been successful all over the world with our agent tested by many independent third parties. And it's part of an NFPA standard now, NFPA 18A. And we'll talk about that a little bit as we go along. This webinar is geared most towards the firefighting community. I know some of you are here from other disciplines and industries as well. Welcome. We have other webinars that are maybe tailored a little bit more towards what you're looking for. But we will talk about those fixed systems and engineering solutions as well. But today we're going to focus mostly on firefighters. Us as firefighters, we're all part of the same tribe, looking to be effective on scene at saving lives and solving problems for the public, and doing so safely, reducing our exposure, getting off the roadway quicker, and staying safe as we do so. Our mission has always been, and is this here at HCT as well, and that's to save lives. And we're going to work on changing the way fires are fought worldwide. So the first thing I want to do is talk about a few of vehicle-related incidents that have been in the news in the last couple of years, and have been significant as far as the impact on firefighters, the impact on life safety in general for the public, and some of the hazards associated with that. We're not only going to talk about electric vehicles, we're going to talk about all vehicles. So here's one, for example, happened in June of 2024 in Los Angeles County. Firefighters responded to the Palmdale Quarry. First engine arrived and began extinguishing this front end loader that you see in the picture when that rear tire exploded that's closest to the camera there. That explosion immediately killed one firefighter and injured another one. Very large tire, large pressure wave, possibly some shrapnel with it when you get too close too quickly, and maybe without the tactics to support that, these kind of incidents can occur. They're always a hazard of a fire. So large tires have been the recent cause of line of duty fire deaths. And tires are not going away. They're getting larger, higher pressures, more plies, more things like that. Some new technology involved in tires as well. Tires are always a concern at a vehicle fire. Here's one from Alicorn, Spain, or Alcorson, I think is the way to say that correctly. It happened also in 2025, where two firefighters were killed in an enclosed parking structure. Um, uh, 7 others were injured. One of those critically. What occurred is a vehicle ran into a fixed object inside of that enclosed parking structure and went into thermal runaway, or what we call thermal runaway. It was an EV vehicle. The firefighters made entry to investigate and began fire attack, and the vehicle exploded due to what we call a vapor cloud explosion. Vapor cloud explosions are likely from lithium-ion batteries. They're not just a tertiary or once in a while hazard, they are very likely, especially when the vapor cloud is initiating prior to full flaming thermal runaway, where that vapor cloud has time to build up, especially in an enclosed area. So a vapor cloud explosion can occur inside of the vehicle cabin itself or inside of an enclosed area where a vehicle may become involved in fire. And that's not only an EV hazard. Any vehicle can off gas. Any vehicle can have even a liquid ignitables gasoline leak, which results in an explosive vapor concentration in that area. So it's a hazard in general, but with electric vehicles and I will say hybrid vehicles, as well as more hybrid vehicles move towards lithium-ion batteries, you're going to have more and more vapor cloud explosion hazards occur as firefighters respond to fires. Our next video covers a recurring theme in vehicles as modern vehicles get more and more of their weight from combustible lightweight metals like magnesium and titanium. You can see from this video, we don't always learn from what we're seeing, but fire departments should approach every modern vehicle fire as if there are combustible metals involved and use the tactics appropriately. You'll see the firefighter in this video was using a straight stream from the fog nozzle and immediately got a hazardous reaction from the combustible metals that were involved. So obviously could probably use a different stream more to our advantage, but we're going to talk to you about some better tactics, more appropriate tactics as well. And then the last, second to the last one I have that involved a line of duty death of a firefighter occurred in Greene County in Georgia, where we're located in 2024, where Battalion Chief Christopher Eddy responded to a tractor trailer fire on Georgia Route 15. The tractor trailer was pretty involved. I'm gonna kind of go out of this presentation for a second and show you that video on a different screen. So if you'll bear with me for just a second, we'll do that. The reason I can't play it in this screen is because there's an extra layer of security because it's sensitive video content. So hang on one second. All right, let's do this now. Fire engine arrives, begins putting some water on the cab end of this vehicle. From what I understand, that trailer was loaded with frozen chickens or turkeys, something like that. Probably a refrigeration trailer. Battalion chief approaches, you know, surveying, blocking traffic, manning the incident, bystander video captures. They began flowing water on the cab of the truck. The cab is kind of disintegrating there, but it certainly appears as if the fire got into the trailer itself, whether it initiated on the reefer unit on the front of the trailer or in the tractor of the tractor trailer truck. I'm not sure. You're going to see the design chief approach the rear doors of this trailer. He does a little bit of thinking whether or not he's going to try to open it. And then, as with most of us firefighters, curiosity, looking at trying to assess the situation, thinking about opening up the back of this trailer. And eventually he does go over and open the back of the trailer. You're going to see as soon as he reaches for that last setup, it doesn't look to me like he even had time to get it open. Doesn't look like he's even got time to get it open. So you're going to see it right about here. So a very, intense explosion. Obviously, from the direct trauma, probably from that door swinging open. Unfortunately, he did not survive that incident. Obviously, there was a lot of products of combustion trapped in the headspace in that trailer. You can see they immediately caught fire. So hazardous cargo continues to threaten firefighters, and that hazardous cargo is always changing. I'm going to go back to the other screen now. Okay, and the last one I want to talk about that's been in the headlines is this parking structure fire with a collapse in Nashville, Tennessee. Crews were called there around 1:22 a.m. in June of 2025 to the downtown library parking structure. We know most parking structures are type 1 fire resistant construction, heavy concrete with pre or post stress concrete, and protected columns, tilt slab or set in place construction of concrete. There are some, however, lightweight construction parking garages now with just curtain walls on the outside, maybe even just vinyl. There's also, some what we call non-combustible limited combustible construction or type 2. But as things have progressed now, because of fires like this one, sprinklers are required in all new construction of parking garages. In this particular incident, as firefighters were fighting this parking garage fire, the ramp from the third to the fourth floor of the parking garage collapsed on top of vehicles, and the fifth floor of the parking deck fell onto the fourth floor. So, these are sudden collapses, usually are not going to have a lot of warning due to the construction type. They're just going to suddenly fail. And unfortunately, that usually results in a very big hazard to firefighters. So another big hazard to firefighters in parking garages is just a multi-vehicle fire. And by the time you get to that situation, several vehicles could be involved. So modern parking construction or structures, excuse me, you could automatically, and I think a lot of people automatically do blame this on EVs, but some of the biggest collapse failures of parking structures have occurred due to internal combustion engine vehicles, fuel leaks, that fuel then running under other vehicles and through the rest of the structure, catching a lot of things on fire, causing spalling and failure of the concrete, failure of the reinforcing steel that's holding them up. You have high temperatures, 1500 degrees Fahrenheit or 800 degrees Celsius, up to 5000 degrees or 2700 degrees Celsius. So you have now where you're having some charging stations show up in parking garages. Many of you probably already have those. The only code restricting the placement of charging stations is the electrical code. It has nothing to do with the fire code, unfortunately. So we're playing catch up on the fire side of things. Fortunately, now there's more and more call for sprinkler systems in those parking structures. We're going to give you some other options as well. The hazards included in parking structures include high-rise building features. So you have stairwells and standpipes and things like that. Rather than your typical corridors and divided spaces, they're wide open spaces. You can have larger vapor clouds, larger areas with zero visibility, running flammable liquids, longer hose lays, limited access to standpipes, and really unfamiliar layouts, especially when you're operating in limited visibility. Electric vehicles, let's talk about those. Thermal runaway is a self-sustaining chemical chain reaction that spreads heat across individual cells in a fraction of a second in a lot of cases, and then multiple cells as that heat spreads in what we call thermal runaway propagation from cell to cell to cell. And in many of these vehicles, there's hundreds, if not thousands, of individual cells. High temperatures and explosions, fires exceeding 1200 degrees Fahrenheit, causing explosive ruptures, spreading flames, not only to the vehicle of origin, but other vehicles as well. Toxic gas emissions, so they're not only explosive gases, they're also very, very toxic. Hydrogen fluoride, carbon monoxide, and just a rainbow of other toxic gases coming out of these vehicles, vehicle fires. And if you think about thermal runaway, it can happen in a way, at least initially, that there are no flames. So it's just off-gassing these toxins the entire time. Prolonged combustion fires can last for hours as that thermal runaway propagation propagates from cell to cell and then from module to module. If you're stuck babysitting one of these things with plain water, you could be stuck there for hours, flowing tens of thousands of gallons of water. Water can't penetrate the compartmentalized battery packs, especially, you've got some different battery construction methods, a myriad of different types of battery modules. And then inside of the modules, you can have either cylindrical or prismatic type batteries. It just depends on what the engineers decided to go forward with in their vehicle design. So you're going to have the gamut of different battery designs, placement, and location in vehicles. We're looking at a regular passenger sedan type vehicle. Well, when you look at SUVs and pickup trucks and over-the-road trucks and then heavy equipment, the batteries could be in vastly different locations, compartmentalized in vastly different ways. And then just lack of standardized protocols, it's still a new and emerging technology. So the engineering and engineering world is trying to figure out, number one, they're trying to innovate. Number two, they're trying to stay within safety parameters, trying to figure out what's going to be safe and what's not. It only took 100 years or so with internal combustion engine vehicles to make them meet a lot of safety standards. It'll be a little bit faster with these, but they're still an emerging technology. So your lithium-ion battery hazards include vapor cloud explosion, intense blowtorch flames that can reach up to, 3 to 5 meters. off of any side of the vehicle. Projectile hazards are likely from lithium-ion batteries, and even vehicles, they can come out from underneath or in different configurations in different directions from the vehicle, and then become a hazard to nearby personnel, nearby combustibles, etc. So some EV era terms. So I don't like to restrict anything to just EVs because firefighters have to respond to all vehicle fires, right? And we don't get a choice. We typically are not even going to know what type of vehicles on fire as we're getting dispatched until we arrive on scene and figure it out. So some EV era terms that you should be familiar with is that they're all EVs. So there's ICEVs, internal combustion engine vehicles. BEVs, battery electric vehicles, or shortened up to EV in a lot of cases, HEVs, hybrid electric vehicles, and then plug-in hybrid electric vehicles. Um, and then when the hydrogen ones do actually hit the market, I know there's people that will say, "Oh, they're already out," but by and large, they're very limited for now. Um, then you have the hydrogen cell electric vehicles. Um, so what we're going to talk about and discover today is that they're all just modern vehicle fires. That's the status quo now. So we have to change how we're approaching all vehicle fires, and they all have hazards that require a structured, consistent, team coordinated response with strategy and tactics that are applicable to all vehicle fires in the face of the new hazards that are contained within them. So we're not just going to EV fires because we likely will not know that it's an EV fire until we arrive, or maybe we're on the way there and a police officer arrives first and lets us know. So our goal here today is to provide you with effective tactical recommendations for all vehicle fire situations as we move forward. The bigger picture, according to previous studies, approximately 36% of EV fires occur while an EV is parked, 24% while charging, and 16% are the result of some type of an accident. It could be an obstruction on the roadway that goes up through the battery pack. It could be a collision. It could be vandalism. It could be a lot of different things that cause those batteries to go into thermal runaways. Not just always charging. It can be aging. It could be dendrites in the batteries. It could be a number of different things. There's one thing that's consistent, and that's that firefighters have no control over what started this fire. And then there's where are they parked? What are some of the added hazards based on the situation? Um, a lot of times we get led to imagine that these vehicles will be sitting alone in the middle of a parking lot and nothing around them, and we can just let them all burn. That's the furthest thing from the truth. If you've been a firefighter for any length of time, you're going to have encountered situations where there are people involved, very high value exposures involved, lots of other vehicles around them, tunnels, parking garages, residential garages. And I don't care if it's a residential garage at a McMansion or a residential garage at the small ranch style home that's 1,200 square feet in the suburb. That home is valuable to someone. So trying to save that home from this vehicle fire is very, very important to those people. Safety advisories that have come out recently on EV fire blankets include this one here from both ULFSRI and the NFPA Research Foundation. Hopefully this isn't too loud. But I'm going to turn this down a little bit because the music isn't very important. So what was found basically was when you use a vehicle blanket, number one, it's a Band-Aid. It's not putting that vehicle out, most likely. It's a time buyer. So there are some positives to that potentially. Buys you time until an adequate fire apparatus and a crew responds and finds a water supply and starts applying good tactics to that fire. However, when you go to remove that blanket, you really have no idea, even with a thermal imager, the status of that fire or what's left burning. So when it comes to an EV, you don't have an idea of the percentage of batteries that are left as stranded energy left to burn. So when you're pulling that off, you're releasing trapped heat, trapped smoke, some flames, and it oftentimes results in a vapor cloud explosion. So it potentially causes another hazard if it's used inappropriately or even accidentally released, removed from that situation at a moment in time that is unfortunate to nearby firefighters. So again, we don't have any control on what goes on under that blanket or the timing thereof. So we're arriving as firefighters, we get what we get, so to speak. And most of you know that. So we get to deal with the consequences of what is on scene occurring when we arrive, and that's all we get to deal with. So mitigating modern hazards more efficiently and more effectively. Safety is born of effectiveness. We're going to help you be more consistently effective on all vehicle fires, no matter what they are, by putting in a simple water additive. And that water additive is called F500 encapsulator agent. It's manufactured by HCT. It works on a molecular level to mitigate flammability, clear up the atmosphere, and help you as firefighters actually save lives when you have to. And there's a percentage of vehicle fires that you go to that will have been involved in a collision or somehow be directly threatening lives. We can't wait for a special tool from across town or across the county to arrive to save lives. We have to be immediately effective right now with the tools that we have on board every fire engine. And when you put F500 on your fire engine, that is exactly what occurs. So F500 delivers three unique benefits: encapsulation of every atmospheric molecule. If you have a liquid ignitable on the ground, it's going to encapsulate that, knock that fire down, make that liquid not ignitable. Rapid heat reduction, we'll talk about how that occurs, but it absorbs heat at up to 10 times the rate of plain water. Free radical interruption, when incomplete combustion occurs, free radicals get released. They result in other airborne concentrations and compounds that are A, toxic, B, explosive. So we're knocking that down at the same time. um, so we like to say, as water flows, so does F500 encapsulator agent. When you conduct your initial attack with F500, on a vehicle fire or any other fire for that matter, you're taking out those explosive atmospheres, you're cooling the atmosphere, you're clearing the atmosphere, and you're putting the fire out exponentially faster. Let's look at what an encapsulator agent is.
The next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet, with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
As you look at this picture on your screen, it is a cutaway of a water droplet. So the blue skin is the outside of the water droplet. You'll notice that water droplet is coated with molecules of F500. The F500 heads are hydrophilic, they like water, so they're going to point towards the surface of the water. The tails are pointing outward. They're the things that grab hydrocarbons out of the atmosphere. And then inside of the water droplet, you'll see it's packed with those little spherical cells. Those are called spherical micelles. And inside of those, as this water droplet formed in the atmosphere, it grabbed those hydrocarbons and stuck them on the inside of these spherical micelles and locks them away from oxidation, combustion, etc. Another feature of this modified water droplet is that it absorbs heat much more rapidly than a plain droplet of water. A plain droplet of water absorbs heat by the mechanism of evaporation or boiling, turning into steam. F500 absorbs that heat into the interior of the water droplet very, very rapidly, like a Ferrari compared to a Volkswagen. So the speed with which it absorbs heat is very rapid compared to plain water. It is near 100% efficient at heat absorption, whereas water is only 7 to 10% efficient at heat absorption. The rest of it just runs off. It's a very, very effective cooling agent, which is one of the things that makes it very, very effective on lithium-ion battery fires since 2008. So an encapsulator agent helps you prioritize safety for your firefighters as it's applied to the fire, especially when used on initial fire attack. So we have several studies listed here. We have, somewhere hundreds of files and dozens of studies on encapsulator agent from around the world that show that, number one, it encapsulates, absorbs up to 98.6% of the toxins in the atmosphere as you apply it. It reduces the accumulation of what we call polycyclic aromatic hydrocarbons that accumulate on a firefighter's turnout gear and on firefighter skin, on fire investigator's skin, anyone associated in and nearby to that incident. It's going to reduce that. It reduces the output or the concentration of hydrogen in the atmosphere two ways. Number one, encapsulation. Number two, rapidly cools those lithium-ion batteries, reducing the hydrogen production in the first place, or the source of the hydrogen production. And then it creates a survivable atmosphere for nearby personnel, nearby victims, etc., as you apply it. And that was done, proven in a study by a group called Atlas in 2023. Lots of studies support everything that we're trying to get across to you about F500. Got over 25 years of testing to show that. So what's an encapsulator agent? Why aren't there any bubbles? It's not foam. First off, we're not trying to create bubbles. We're trying to create a solution that encapsulates every molecule of trouble at the fire. And every molecule at a fire is trouble because it's trying to oxidize, vaporize, and combust, and then turn into either something that's explosive or will burn you on contact or cause smoke inhalation to you and your victims. So we're trying to handle this thing, and we've proven for many, many years that our agent does that very effectively upon application on a molecular basis. And it does so better than any foam has ever performed in history. We fight more than fire, like sand. We absorb these toxic compounds that are part of combustion. And I might say lithium-ion batteries, but they're part of all combustion. We carried a lot of hydrogen cyanide monitoring equipment when I was on the hazmat team to try to prove that hydrogen cyanide was not in the atmosphere during fire overhaul at structure fires. Same with carbon monoxide and a lot of these other compounds as well. They're all toxins. When they're present in the atmosphere, they kill people and they harm firefighters. F500 takes them away. F500 can be used for all hazards. That's what we're saying. This is for all vehicle fires. It's very, very efficient on all classes of fire. It doesn't require a lot of retraining other than the fact that make sure it's in every line all the time on initial attack, and your fire is going out quicker. You're going to go home quicker. You're going to get off the highway quicker. You're going to cut your risk down because you're not going to be on scene as long. You won't have the overexertion. You won't have the exposure. Your incidence of cancer and cancer-causing agents in the atmosphere will be greatly reduced. And much of that reduction is because just you're on scene for a lesser period of time. So what do we mean by free radical interruption? What I want you to do is watch the vapor cloud above these tires as these firefighters go ahead and extinguish these tires with F500. Tires are considered an ordinary combustible class A, but they do turn into oil as they break down. So you could kind of make it a combination hazard there. But one thing we know is they burn intensely. They're hard to put out. They put off a lot of black smoke. So keep an eye on the vapor cloud. That vapor cloud is gone as soon as they start hitting us because we're interrupting free radical coalescence. We're stopping those free radicals from coming together and creating those new airborne compounds, which are toxic, explosive, etc., 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 cancer causing as well. So this this test was done at the Fire Insurers Laboratories in Korea. This is a brand new 64 kilowatt hour EV at 100% stated charge. The next video is going to show you the results of the thermal runaway and fire incident. It was allowed to pre-burn for 14 minutes and get into, really good solid thermal runaway before the fire attack began. And then what you're going to notice is there's an under vehicle nozzle and then a firefighting nozzle. That's why we recommend two lines at these modern vehicle fires so that you can attack from two angles, put one line under the vehicle if needed, but you still got your primary attack line doing a lot of the work. And these lines that they're using, just to preface this a little bit, they're both normal looking hand lines for the US, but they're actually flowing a little bit less. They're both 50 GPM or 200 liter per minute lines. Keep an eye on the atmospheric conditions.
To meet the unique challenges.
I'll turn down the volume a little bit, but so you'll notice in the clock on the left at the top, over 14 minutes into the burn, the clock in the red at the top are the seconds of suppression time. So I'd love to see in chat your best guess as to how long it takes to combat this fire. So how much time in minutes, how many gallons you think it takes to suppress this fire, bring it all the way under control. Just throw your best guess into chat. Keep an eye on that atmosphere. So typical garage fire, what do you know about that? When there's a vehicle in a garage, they get really dark, really black, in a big hurry, and it doesn't improve for quite a while, typically until you force ventilate it. So this fire was brought under complete control, extinguished permanently with no reignition in 8 minutes and 30 seconds with 850 gallons of water with 3% F500 encapsulator agent. Did we make a bunch of bubbles? No, we just turned the water a nice milky color by adding F500 to it, and that's what you're looking for when you first start discharging to see if you've got F500 in the line. By the way, a quick tactical tip there, look for the milk. If you got milk, you're ready to attack. Um, but the atmosphere was kept clear in that garage the entire time. It improved as the fire attack progressed. And they used their normal firefighting lines. They did not use air aspirating nozzles, no special equipment, just good firefighting tactics and team coordination. They did, in this case, put a nozzle under the vehicle to cool the battery pack itself, but it may or may not have been necessary. That's something that we ask you to consider on all fire attack moving forward. So there's a lot of ways you can apply F500 as a solution based on the size of the fire. And we don't recommend anything smaller than a municipal fire engine or pumper for vehicle fires. And we recommend at least 1,000 gallons of water arrive on the scene. Also recommend that you have 2 crews instead of 1 crew from now forward on vehicle fire task force dispatch. We do have these trailers available for your larger incidents, like maybe a semi-tractor trailer. We've had several of these occur in the past, I say 4 or 5 years, where I don't know why, but it seems like fuel tankers like to crash and catch fire under an interstate overpass. It's their favorite location. But you've also got railroads and things like that in your community, parking structures, etc. We have trailers available with what we call a diamond doser, so it can pump right into the fire department standpipe and sprinkler connection and not lose the ability to proportion like an eductor would. Premixing versus eduction. Yeah, it's cheap to use that inline eductor. It's better to tank mix. It's better to have your onboard programmed foam system because we're trying to mitigate explosivity with the first attack. We're trying to put the fire out quicker so we have less cancer exposure, less chance of flashover, and more immediate encapsulation of any flammable liquids that might be on the ground. We want to save lives when we arrive on the scene, not wait for a special resource to arrive or wait to set up a line. We'll talk about strategies for, deployment, especially when you get when you adopt F500. We're going to help you determine how much you should be carrying, but if you can carry enough to cover all of your onboard carried water, that's a good start. But then also you need to look at things like what are your primary target hazards in your community, knowing you're going to use this stuff for a lot of different hazards, not just vehicle fires. We do have what we call every vehicle firefighter training certification courses available through HCT now. We call it EVFF for short, but EV doesn't stand for electric vehicles. It stands for every vehicle because we want to show you how to apply and use F500 on every vehicle fire to get you off the scene faster, save lives, reduce exposure, reduce risk, and get the job done more effectively. Though most EV training programs, there's many of them out there that actually charge money to come out and teach you how to let it burn, cover it and let it burn, submerge it and let it burn, or rely on scarce, expensive technology, which is not effective at saving lives or time. So a lot of those place firefighters and the public in harm's way for extended periods of time. They don't mitigate vapor cloud explosion, they don't mitigate emissions, and they don't mitigate risk. They all of those methods I just talked to you about add burdens on fire service resources and staffing, because if you're stuck babysitting a vehicle fire for hours with tens of thousands of gallons of water, you're just adding to your fire department's challenge to fulfill its mission. So our EV courses that we have available, EVFF, Vehicle Fire Hazards in the EV area. It's an awareness level course, 8 to 12-hour conferences, your weekend style conferences. We have the F500 EA certified every vehicle firefighter specialist. That's a 16-hour course and it gets your hands on. All of our F500 certified firefighter courses focus around hands-on training. So you're going to get best practices training, good team-based coordination, best practices SOPs, and we include the SOPs with the training. We can also certify your training instructor cadre in how to deliver this training. Our AVFF training involves and includes these 7 modules: assumed conditions, hazards and characteristics, your different vehicle types, fire incident situations that complicate vehicle fires, equipment and technology solutions, strategies, tactics, and expectations, and then special considerations, things like enclosures, parking garages, etc. We use NFPA Instructor 1 instructors to register, train, and certify your firefighters. Our metrics surrounding this training is improvements of things like life threat, risk, time on scene, water, resources, emissions, reignition. We can tackle all of that with this training and better technology to approach vehicle fires, and that includes F500. All vehicle types are included. How many of you from different walks of life from the other person that's also on this webinar with you? You all are in a different situation. You all have different threats based on the vehicles that occupy your territory. This system is designed to work with all of those, provide good quality tactics and technology and a full solution to all of those situations. We're not going to show up and tell you, oh, you can't put those out or you got to wait for a special resource. No, we're putting that special resource in your hands on initial response. Real technical solutions, real tactical solutions, life-saving, best practice solutions. Here's an example. Our recommendations for SOP involve 2 100 GPM attack lines in every vehicle fire initially, a task force involving 2 crews plus your water supply plus your supervision, special resources like buffer zone resources for safe roadway operations, advanced life support if there's any report of injuries, heavy rescue if resources if anyone's trapped or reported trapped, and being ready to flow F500 at 3% with that first line. Class B fires often require a second attack line. There's a chance of explosion if the fire is confined. Our SOPs deal with that. Second line can become the under vehicle line if the vehicle is basically brought under control by the first one. The rig placement, uphill and upwind, very important that you maintain a good buffer zone from the vehicle that's actually on fire. And then things like always wearing your appropriate structural turnout gear with SCBA, air monitoring, thermal imaging, and then added resources for special situations like parking garages and so forth. Comes with SOPs included as a template for you to apply to your fire department. And it meets we actually require some minimum training levels for entry. We believe strongly that firefighters should have certification level training prior to attacking or being sent to vehicle fires, and that includes NFPA 1010 equivalent training. Again, our F500 EA certified firefighter training program involves hands-on, realistic firefighter training. We're not going to just show up and talk about how to put a fire out or talk about that you can't put these out, because you can, and you can save lives, and we're going to show you how. A lot of the courses that are out there, again, don't want to bash on anybody, but they offer, no real solutions, but they sure charge for them. Again, our mission is to transform how firefighters are fought worldwide, how fires are fought worldwide, excuse me. HCT is the only company that's been involved in the EV fire suppression for over 15 years. We do offer fixed system solutions as well. So if you are here from the engineering community and would like more information about that, you can inquire through our website. We are the EV Fire Pro dealer for the US now, and we offer full system solutions, MyCell mist systems, deluge sprinkler systems, along with the EV Fire Pro as well, and proportioning solutions, detection solutions, etc. But the best thing you can do for your firefighters is to adopt a F500. Get some in your hands, get a demo scheduled through your local distributor. You can inquire about that on our website. Um, uh, we want to put this in your hands so that you can try it and prove it for yourself. We realize that you need to see to believe and to try it for yourself, and we're here to facilitate that. Were used, adopted, and tested by agencies and entities all over the world. Got close to 30 years of testing under our belt now, and 15 of that in lithium-ion batteries. With that, we're ready to answer some questions. So if you can please put your questions in chat, we'll definitely try to answer each and every one of them. And if you don't have time for that, we do appreciate your participation today. This is recorded. You will get a copy of it if you're registered. So fire away with the questions. Let's start answering them. Okay, I'm navigating to the top here. See, a lot of people want certificates. Trying to find the first question.
I think a good deal of people did use the Q&A box, Dan. There was one question about testing regarding true Class C fires, like a live wire, transformer, etc.
Okay. Where is that one here? What time approximately? Then I can find it.
It is around 12:41. I answered Andrew.
12:41.
His question
Okay.
is from
Let me
12:38.
I'll scroll down to that. I think I'm at the right location here. Can you confirm why this can be used on a true Class C fire like a power line? Will the stream still create an arc electrocution hazard? It's no less or more conductive than a stream of water. So if you use a broken stream and appropriate standoff distances, we have testing from Con Edison in New York where they conducted testing with appropriate standoff distances. And we do like to give you extra training if we're going to use it on Class C fires, so that your firefighters are aware of appropriate standoff distances and stream types. But it is used on a lot of transformer fires. As of even a couple of weeks ago, FDNY used it to put out several underground transformer fires, and they use it frequently for that. So transformer fires are a big part of what is accomplished with F500. Broken stream application, encapsulation of the hot oils, rapid cooling of the high density transformer, very common situation. The standoff distances at the Con Edison facility that were tested up to 345,000 volts, and looked for a return current to the nozzle, and basically with a handline nozzle fog pattern, your approach should be 25 feet or greater. Shouldn't go closer to that until you can confirm it's been de-energized, but it is applicable. So as is the goal with any Class C fire, you're looking to de-energize the circuit as soon as reasonably possible, and then keep applying as to what's on fire after that. Can you prove that everything is de-energized every time you're approaching a Class C fire? No. And often when we're approaching something like high voltage DC electric vehicle fire, can be 600-800 volts in some of these SUVs. You're looking at a DC charge there. You're looking at stranded energy. You don't control how far you are in the incident until you arrive, or before you arrive. So there's going to be a percentage of that battery and that stranded energy left. It's DC. It's trapped in that battery until it creates a complete circuit through a load. And that load is typically going to be something near the battery, but could it be a firefighter? Yes, but it's never been a firefighter to our knowledge, and we've never heard of it being a firefighter unless they were digging through something inappropriately after the fire. So approaching from a firefighting aspect with a firefighting stream, especially a broken stream, electrocution is not a hazard with EVs unless there maybe is a power line down on the EV, just like it has always been a hazard at every vehicle fire. You always look at your surroundings for things like power lines down, etc. To get a DC charge through your body at an EV fire, you have to complete the circuit from the anode to the cathode of the battery or whatever's left of the battery in stranded energy situation where maybe there's 50% or 25% of the battery left, and therefore the battery charge, when you arrive on scene, you get it knocked out quickly because you're using F500, but then you approach it with a Halligan bar and start digging around in there. That's when you're going to get shocked, is when you dig around in there. And that's where there's actually been a couple of explosions, arcs, etc., that have killed fire investigators. Why you would want to investigate the cause of an EV fire is beyond me, because it's a burn up asteroid that you can't identify and it's very dangerous. Just ship it off, get another one. But uh, it's a good question. Good question. Hope I answered it appropriately. Got a lot of good guesses on the times there. A lot of you guessed pretty high. The thing I would like to say on the gallons and the time is when you use F500 at 3% with your initial attack lines, and you're using the 100 GPM plus attack lines, you're getting your total water consumption and time on scene back down to what it used to be and what it always has been for ISA vehicle fires. So typically less than 1,000 gallons, less than 10 minutes to extinguishment. Very, very typical for these. So if you're responding, some of you have 500-gallon booster tanks, some of you had 1,000, some of you have 750s. Responding with 2 crews, enough firefighters to handle 2 lines as a task force response on vehicle fires from now forward. You're going to be pretty safe, especially when you're flowing F500. Looking for the next one here. Okay, so will you be addressing the results of the UL FSRI testing that showed water by itself worked just about the same as F500 on a full scale US made EV fire? Yeah, we'll address that. We probably got Ron Lowry who was there, but if you look at the amount of water that was applied, the time, and the fact that there was good battery intact still left after the F500 was applied, you'll see the difference there. And by and large, with the one thing that plain water did not do and does not do, it does not mitigate vapor cloud explosion potential. It pushes gases around, but it doesn't encapsulate. So, and we know F500 absorbs into I call them the interstitial spaces in batteries much better than plain water. It cools much better than plain water. Overall, you're going to find a better outcome with F500 than just plain water alone. And not only on vehicle fires, and not only on a specific type of vehicle fire, that's going to be your structure fires, flammable liquid fires, which are just as big of a hazard at vehicle fires, etc. You want to be ready for all hazards. You flow F500 with the first drop of water, you will be on scene for a lot less time than with plain water. As we've shown many cases here in the US, tens of thousands of gallons, hours on scene with plain water. So I don't see how anyone can really make an argument for plain water. There's been videos, plenty of videos going around the internet of completely submerged vehicles still on fire in plain water. So we have a lot of links and references on our website to testing. We can also, if you specifically inquire about those, we'll share those with you. We have a lot of testing. So we've got the A+ testing, we've got testing from um, HHI, Heinrich Hertz Institute, which is part of the TU Clausthal University system over in Europe. Um, uh, Testing really from all over the world by a lot of different agencies, not only on full vehicle fires, but lithium-ion batteries themselves in different situations. So, and it's NEN certified in the Netherlands. So there's an actual certification in the Netherlands. There's not an NFPA certification. There's no hazard class for lithium-ion batteries under NFPA. They're not a Class D hazard. They're really not a Class A hazard, other than the rules of NFPA say that if it's not one of the other classes, then it's a Class A. But as we all know, plain water is not very effective, even when it's underwater. How much for a gallon of, or excuse me, 5 gallons of F500 encapsulator agent? Much less than fluorine-free foam. And we know fluorine-free foam is a really poor performer on anything. Anything that a firefighter approaches, it works at a much lower percentage and scale, consistency wise, as compared to the legacy AFFF and AFFF AR. Because there's no PFAS in it, it tends to blow away. You have to pile it really deep to make it work at all. It breaks down much faster in the presence, especially of polar solvents. F500, you don't have to worry about that. We're encapsulating every molecule. We're not trying to create a bubble surface and trying to maintain a bubble surface. You're attacking it aggressively, encapsulating every molecule. You'll be out of there in a fraction of time. Your firefighters will be safer. As your firefighters move forward through, say a pool of fuel, we've got recent video of this. You're not worried about fire coming up around their feet or anything like that. You're neutralizing the fuel as you're moving through it. So Rick Chartel asks, foam standards have clear application rates in terms of gallons per minute of solution per square foot of hazard based on experimental data. And I will point out that that is very experimental, because in real life we know that foam fails probably a great percentage of the time in real life because of things like wind, structure and obstructions in the pool, running fuel, which it was never meant for in the first place. So it's really applicable to a very limited lab-oriented standard, and that's it. But are there similar data available for F500 application planning? Absolutely. So 0.2 GPM per square foot or 8 liters per minute per square meter for uh, pooled liquids, running liquids, spraying liquids, etc. And then when it comes to lithium-ion batteries and things like uh, overspray, how much is actually hitting the battery versus hitting just the surrounding areas and going past the battery, etc. 1 to 2 gallons per minute per kilowatt hour seems to be a very valid standard. Sometimes that's actually overkill, but if you can apply it for somewhere between, you know, 2 and 10 minutes, you're going to put that fire out. As we saw in the vehicle fire from earlier, had to put out some hidden fire here and there in the vehicle based on the remaining structure and getting the stream into the right places. But other than that, if you can cool it from a couple of angles for consistently for a few minutes, and it doesn't matter what kind of fuel we're talking, A, B, D. D, we want a gentle cooling shower so we're not, disturbing the material and making it airborne again. You want a gentle, cool rain, and you're going to overcome those Class D metals fires with no reaction at 3% F500. You're cooling, not making it react, not making it airborne. It will go out fairly quickly, and it's pretty interesting to see as well. And then lithium-ion battery fires, which are they're not a metals fire. These are not primary lithium batteries, they're secondary lithium batteries. So a primary lithium battery was the kind your grandmother used in her flash camera to run the flash bulb, and or that might be in a remote control or something like that for your fob on your vehicle. They're a one-time charge and they do have some combustible metals and some lithium. But a secondary lithium battery is a rechargeable lithium-ion battery with lithiated electrolytes, an SEI layer, and a couple of anodes in it. There's not any lithium metal in it. Shelf life of F500 is 15 years. Um, uh, F500 works with ultra high pressure or UHP systems excellently. The more you can atomize the water, the better. If you inquire about the cost of the training classes, we will send you a proposal on those, but they're pretty reasonable. I have a question about, can manufacturers put an alarm in an EVA vehicle to identify them as you approach the fire? They certainly could if they're electric, but might not be working anymore when you get there. That would be the potential hazard for that. Can FB500 be installed in a wet pipe sprinkler system? Yes. We have proportioning systems available for systems use, whether you're going to do deluge, wet pipe, etc. But we want to help you through the design application of that so we know it's being installed appropriately. F500 is compatible with salt and brackish water, whereas your fluorine-free foams are not. So we've got Ron Jenkins asks, how does F500 stop thermal runaway if battery cells cannot be directly cooled, as is the case most of the time? Well, first off, I'd like you to qualify most of the time based on experience. That's not the case. By the time the fire department arrives, those batteries will be showing themselves due to auto exposure. The case will be burned away, etc., etc. So we are going to get a stream into that battery. We are going to get solution around that battery. And we've also got evidence from a fire over in Germany in a test cell where F500 floated strictly on the outside of the battery module enclosure and still stopped propagation of thermal runaway and brought that incident to a fairly quick close. Much it stopped the incident. You can argue all day whether or not you're stopping thermal runaway or not, and I don't think you are in an individual cell so much, other than the F500 absolutely encapsulates electrolytes, and it's been tested under NFPA 18A section 7.7 on the electrolyte itself to do so. However, uh, theoretically at least, I think we're probably more likely stopping that heat transfer from cell to cell more often. We're getting into what's left, and if you see a lithium-ion battery on fire that's peeled open and it's uh, envelope or prismatic style or whatever, you see all these layers in there, and you see the F500 getting in there and working close up. It's pretty obvious that it's providing advanced cooling in between all of those interstitial spaces between those materials, much better than plain water, because partially because it's breaking down the surface tension, but also because it's a much better cooling agent. Mark Baldino asks if you could apply a 500 20 seconds after battery fire started, how effective or how many gallons would you think self-contained system? So a lot to that, but the sooner you stop it, the better. The sooner you stop thermal runaway and thermal runaway propagation, and the fewer cells that are involved, the less heat has a chance to build up. And we do sell fire extinguishers, handheld fire extinguishers, wheeled fire extinguishers, carts, etc., for manufacturing facilities. The sooner you can apply it, the better. The less material, the less heat gets in, built up in the system, the quicker you can mitigate it. But by and large, as firefighters approach a vehicle, like the picture in the background here, that thing's going to be a percentage uh, consumed by the fire by the time a fire department arrives in most cases. And you're going to be fighting it with firefighter streams, not handheld extinguishers. Handheld extinguishers are not appropriate for large batteries. They're appropriate for very small batteries like cordless tools, things like that, laptops, etc. The wheeled fire extinguishers, so slightly larger things like um, uh, grouped batteries, like a lot of, larger lawn equipment and things like that have the bigger battery modules. And then if you're maybe plugging several of those into your lawn mower to get your lawnmower to do the whole lawn, that's quite a bit of kilowatt hours there actually. So, and you're going to be talking more like a wheeled fire extinguisher or something like that once you get to those grouped batteries, multiple batteries. Um, APUs for RVs, auxiliary power units. They're getting away from generators and going to just bigger battery energy storage units. It take multiple extinguishers or wheeled extinguishers to put out a bigger battery like that. So again, 1 to 2 gallons per minute per kilowatt hour, sustained over a few minutes so that you can keep cooling, keep applying, and you're going to overcome that. The nice thing is you're also overcoming that explosive and toxic vapor cloud at the same time while you're applying. So what's the cost effectiveness in comparison to foam? Number one, you're going to be on scene a lot less time. Foam I call spray and pray. There's never been an above ground storage tank fire successfully extinguished with foam larger than 50 feet in diameter. And uh, why it keeps being specified is because, there's a big, strong industry behind it, which, kudos to them for making money, but it by and large fails. I would ask you to put in chat the last above ground storage tank fire you saw successfully extinguished with the tank still intact using foam. Um, I don't know of one. They all burn to the ground or boil over, the tank fails. So, cost effective structure fire, you might use 1 or 2 buckets and then you're off the scene, but you're avoiding a long time on scene, you're avoiding overexertion, heart attacks, you're reducing cancer exposure, you're getting your personnel off scene faster, making them available for the next call faster, reducing the contamination on their turnout gear. So I would say as compared to what. And then also as compared to foam, you're using a lot less because you're putting the fire out in a hell of a hurry compared to foam, where you're praying that you ever get the fire put out with foam. Um, uh, Brian Flaherty asks, we recently did a demo and placed it into service. We also added F500 PWs to our toolbox of equipment. We discussed last evening when to go for that PW versus standard water. What is your recommendation on which PW? I'm assuming he's talking about a PWE, pressurized water extinguisher. In that case, you're using, if you charge that F500 handheld extinguisher, you're adding 10 ounces. So literally, a fraction, 1/10 of a gallon. You're not adding like a bunch of money. Put it in every fire extinguisher. It's good for every fire. There's no fire that is not going to help you on. Ricky Vernier II asks, fog nozzle only. No, you can use it in a straight stream or a smooth bore, but it's much more effective in smaller droplets. Just like if you take water mapping classes from UL or whoever, you're breaking it off of a wall or you're breaking it off a ceiling and it's breaking up into smaller droplets after it cools that surface. So in an interior structure fire, for example, you're using F500 and a smooth bore, it's going to cool the walls, make them much cooler, much faster, less likely to reignite to the point where you're eliminating flashover in a hell of a hurry, clearing up that atmosphere. Fog nozzles are more efficient at heat absorption, which is part of what we're going for. We're also going for vapor cloud, gas, smoke encapsulation, and interruption of the free radical coalescence at the same time. Fog nozzle's your friend in that case. Smooth bore nozzle's going to work a lot like a smooth bore nozzle works with plain water. You're going to get slightly better results with F500. You're going to get more permanent results with F500, but a fog nozzle, even a hen nozzle, if Ray is listening, is going to be your absolute friend for high performance, rapid fire out, get get the job done, save the life, get off the scene. Okay. Joseph Chaplinski asks, once a fire is knocked down, how is F500 controlling the runaway? Are we continually using F500 to cool the battery, or are we changing tactics? So, good question. Good way to frame it. So when you are using plain water, even if you put it in the ocean, for example, uh, plain water does not really get into those interstitial spaces in between the batteries the way F500 can. And when F500 gets into those interstitial spaces in between the battery cells and even into the materials as these batteries are coming apart and separating under high heat, it encapsulates, it absorbs, it cools, it buffers against the heat transfer from another battery near it. So yeah, you are continually cooling, but you're continually cooling at a rate that is 10 times more efficient than plain water. So you're having to cool for a much lower, less period of time. And then your reignition chances are a lot less with F500 than they have been with plain water. And that's because the material does get into those interstitial spaces and it keeps working for a period of time of days, weeks, etc. Um, you'll you'll notice if you read through a lot of stories of plain water extinguishment, either in a test situation or an actual fire situation, there's been reignition later on. Uh, we haven't had that result with F500 on either test or real fires where it's been used. Once you get it all the way put out, since it's wetted with F500 and the F500 is is in there with the batteries, and finding its way in between the cells and the materials. It really helps absorb that heat continually um, until the battery itself naturally degrades in energy. The stranded energy disappears. A lot of times during post-fire handling, the vehicle gets drug up onto an aluminum flatbed that's got those ridges, gets twisted, gets bent over an edge, gets thrown around at the recycling facility. The batteries receive secondary trauma, which throws them into a new thermal runaway because of stranded energy. But by and large, you're going to see a better result, a lot less reignition once F500 is introduced to the battery. Santiago Draper asks, I have one doubt. The FAA has approved the F500. Do you have any list of clients using it after the fire on board? What happened like 2 months ago? Would HCT have a portable extinguisher for laptop batteries? We do have portable extinguisher. They're a 2.5 gallon portable fire extinguisher with 3% F500 or 10 ounces on board inside of the fire extinguisher. They are a broken stream or a misting head on the extinguisher for best performance on lithium-ion batteries and the explosive gases that surround those batteries. So I have no doubt that if the extinguisher was handy in that situation, because they're already NEN certified, they will absolutely handle up to about a 3 kilowatt-hour battery. It's actually been tested up to a little higher than that, but for a novice user who's probably, freaking out a little bit, and the gas cloud and heat, flames shooting around inside of a cabin, luck, fortune, etc., comes into that as well. But with a good application and good cooling, they're going to control the atmosphere and stop that incident very, very quickly with the handheld extinguisher. Can you apply F500 at 100% or no dilution? I don't know why you would want to do that. That's not how it's designed to work. It's a water additive with its critical micellar concentration being at the optimum at 3%. After almost 30 years of testing, you would never apply it at 100% concentration, but that way. Has there been any departments that have F500 on their rigs where the seals in the pump have deteriorated? No. However, sometimes tanks, as we all know in the fire service, get loose fittings. Valves get bad. Valve seats get bad. F500 having a lower surface tension than water, just like Class A foam does, is going to find bad valve seats, valve face, scores in ball valves, things like that. Get the valve fixed, get the seal fixed, the problem goes away. What is the recommendation for how to treat the EV after the fire is extinguished? Justin Myers asked that question. So, great question. So post-fire handling of an EV, that's a good time for that tarp. Cover it, wrap it up like a burrito, drag it onto that flatbed, preferably with a tarp under it so you're not dragging that raw battery components over that corrugated aluminum surface. Get it to a segregated lot, 50 to 75 feet from any other exposures, and let it sit for a week or two, just so it's not catching other exposures on fire in case it were to go back in thermal runaway. Some departments like to escort it to the impound yard, but that's totally up to the department. It can be tank mixed, and it's perfectly fine that way. It does not settle based on the way it's formulated. With the hydrophobic parts and the hydrophilic parts, it stays very well diluted. And then when you're driving to the scene, obviously that would stir it up a little bit more anyway, but it can stay in that tank. It doesn't reduce its shelf life if you tank mix it. Plus, then we know you're going to be using it on the next fire, so you're going to have to refill it out of a new jug anyway. One of the challenges for departments is, what did the last driver do? Did the last driver add more F500 to the tank or didn't they? So you have to coordinate very well between drivers and between shifts and so forth to make sure there's still F500 in the pre-mix tank. We have a lot of departments that run with 1% on board and add the other 2% as needed from their foam system, or by just jumping on top and dumping the other, couple of jugs in the tank. So you get your 3% at that point, but then you're always starting with at least 1%. If it's utilized through a foam proportioning or proportioner tank, does it need to be flushed out every application? So no, it does not need to be flushed out of the tank. However, if this tank was previously used with an AFFF product, you're going to want to make sure and flush that entire system completely, very, very well, at least 3 times. Then you refill your foam concentrate tank. And then after every use, if you've got Foam Pro or some other brand of a electric injection unit, make sure you run plain water through that after each use. And just to keep it clear and make sure that, we're not having chemical sitting in the foam proportioner unit itself. You have clean water sit in there. And then that helps maintain that unit, clear debris out of it, etc. Make sure that your fittings are tight on the bottom of your tank. You don't have leaking valves, so the more product leaks into the foam system in between uses, things like that. So it's just good rig maintenance, important, just like it always is. Um, I failed to answer Christopher Hamill's question. How much does a 5-gallon pail cost? About $180. So compared to things like your Foz Check WD-880, it's going to be $10 to $15 less than a 5-gallon pail, but it's going to serve all hazards, all classes of fire, whereas your different types of foam are only applicable to different types of fire, and you're going to use a lot less. So apologize that I missed that. And that is through a distributor. Their list price on it's about 185. There might be a small price increase soon, so get it while you can at a lower cost. But most of the distributors around 185 a pail. Here in the US, that is, not internationally. Okay, Mark Baldino asks, onboard automatic nozzle system with pump, okay, suppressant bag, circuit board, activated by battery fire, applied immediately, 3% dilution. I'm not sure I understand that question. If you could restate it, Mark, or just email it to one of us, something about a firebot suppression. And I'm not sure I understand that question, sorry. If you exit now, as you find, you'll get a recording or a link to a recording. I'm going to look into that firebotsuppression.com, Mark. I'm sorry, I don't know anything about it right now, but we'll look at it. What is the percentage per 1,000 gallons of water? So Class A and ordinary combustibles, 1%. Almost all other hazards, 3%. So 30 gallons. So John Borkowitz asks, I work for a global ro-ro shipping company. That's a roll-on, roll-off shipping company. Company controls approximately 125 vessels across global operations. They have a mix of CO2 and water and foam applications. What would be the recommendation to switch from AFFF to F500 and cross the fleet? The cargo is primary rolling stock, every vehicles and heavy equipment. So obviously every ship and the vintage of every vessel is a little bit different. So we'll need to kind of look at your onboard systems in general and what you have. But we can typically reapply F500 at 3%, meeting the recommended sprinkler density, and switch you away from the CO2 and water foam applications and get you one that'll actually work. So we know of two, at least, one in the Atlantic and one in the Pacific, ro-ro ships that burnt up completely. One sank, and there wasn't enough water in the ocean to put them out. So F500, especially when you detect it early, catch it early, you're going to stop that. You're going to stop that incident in its tracks. You're going to continue on your voyage, deliver the rest of the vehicles, and then just take care of the, one or two or three of them that caught fire. But F500 will absolutely stop that incident, will absolutely save the crew and the ship if it's applied early and in, I would say, the right application density. So that's a job for our engineering support staff. Dante Hewlett Jones, are there any other departments that currently use F500 that have had problems with seals in their pumps deteriorating or people complaining of skin irritation when maintaining F500 on trucks? I would say in our 30 years that we've had a couple of instances of people having problems with seals in their pumps. F500 with certain types of hydrocarbon seals that have been used over years by certain manufacturers have a little bit of an issue here and there occasionally, especially if there's a loose fitting or a loose connection where it can leak through. But other than that, we've had very little trouble with anything like that. As far as skin irritation, we've got animal testing skin irritation, which we will share with you, that shows there really is none. I've had it all over my skin multiple times. If you've got existing sensitive skin problems, um, I would imagine it can exacerbate that in certain situations. I even use the wrong laundry detergent and my skin gets irritated. So I'm not saying that everybody's the same, but we've had very little trouble with that, especially if you wash your hands after you've been around it a little bit, rinse them off with plain water, um, and maybe use some soap and water. I would do recommend that when you're working around it, know that you're going to get it on you, that you wear at least medical grade, uh, Biton or not latex anymore. Trying to think of the glove chemical that you buy at the hardware store, something like that. And part of that is so that once you peel them off, if you rub sweat out of your eyes, you're not rubbing an irritant into your eyes. And like any surfactant, it can irritate your eyes a little bit if you rub it in there, but eye drops will take care of that. Does it require a brand specific external eductor or can it be used with the existing AV foam eductor? It can be used with any existing eductor, but if you have specific questions about your eductor, make sure you inquire through our website or with your local rep or distributor. We can answer those questions specifically. There's typically no problem with compatibility. Um, as Heather and Ron both mentioned, as far as marine solutions go, for onboard ship firefighting, and our product, if you ever heard of the Sunnion oil tanker that got attacked by the Houthi, and set on fire, and then they blew up some tanks and so forth. F500 put it out. In a day or two, working tank to tank to tank. There were like 12 different onboard tanks on fire. F500 put it out. F500 also stopped an off-shell oil well fire that had a foam applied to it for 7 days. F500 put it out in 7 minutes. So it's really a different kind of product than foam. We have do systems for uh, every type of situation though, and we can help you engineer those solutions. So that's the last question I see, which is good because I'm running out of voice capacity here. Yeah, I really appreciate all of your good questions and all of your participation today. We'll be getting the link to the copy of this recording out to you, as well as your certificates if you requested them. And again, we really appreciate your time and involvement. We want to get this stuff in your hands so you can try it out, prove it to yourself. We know that when you use it on a few fires, uh, we're 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 solid believers that you will really like the benefits that it provides and the difference that it makes in your firefighters' lives. So everyone, thank you again and have a great day. Thank you, Heather, Ron, etc., for helping answer some of those questions. Have a good day, everyone.
Thanks, everyone.